Okay, self-inverse functions. So this is something that they added to the IB curriculum in the last round. And it's not really a huge concept, but it's something that they wanted you to be aware of. We kind of already talked about inverses. Actually, I guess we didn't quite review that yesterday, although we talked about it in 20 IB, that when you take the inverse of a function, and you take the function, so you take f of the inverse of f, you get x as your answer always. Okay? So now we're looking for functions where that happens, where the inverse is the same as the original. Okay? And those are called self-inverse functions. So take a look at the graphs. They're on your graph paper. If I ask you to find the inverse, there's the equation of it, but it's graphed for you. So reflecting in the line y equals x. Well, or taking points and interchanging them. So 1, 1 here, the inverse is 1, 1. 2, 0 becomes 0, 2. So they're not all invariant points, but they all end up on the same as the original graph. 0, 2 becomes 2, 0. What's that? 4, negative 2 becomes negative 2, 4. So you get all of the same points. So the inverse, I'll just graph over top of it, basically. Okay. This next one, all of these, this is just a set of points. Okay. Here, negative 5, 4 becomes 4, negative 5. Negative 4, negative 2 becomes negative 2, negative 4. So 1, 6 becomes 6, 1. 2, 3 becomes 3, 2. 3, 2 becomes 2, 3, and backwards, right? We've done all of these. So they end up, the original and the inverse are the exact same function. Same with y equals 1 over x. Because if you draw that line, y equals x through there, you know that it's, if you folded your paper in half, they'd overlap. If you folded along that line, all the points would overlap. This, they'd overlap. Okay? So when we do our inverse here, it's going to be the exact same function. Okay? Those for graphs. Question 2, there are ordered pairs or equations. So find the inverse of the set of ordered pairs in A. Find the inverse of the function y equals 1 over 2 of x. And find the inverse of f of x equals negative x minus 5. So I'll give you a couple minutes to do that. Based on the information from question 1, probably your inverses are going to be the same as your original. But do the math and make sure that they are. Okay, and then with the equations, solve for y, okay? We practiced that yesterday. Okay, so this is function notation. So when I find the inverse, I can use that f inverse of x. Notice now in all of these, I got the same as the original. So 7, negative 5 was that one, there, 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 and there. So the original and the inverse are the same. The original and the inverse are the same. The original and the inverse are the same. Okay? So what do you notice? So the original and the inverse are the same. Okay? So determine f of f inverse of x. Okay? So that's basically the C in question 2, second question. So we're finding f of inverse of x is negative x minus 5. And that's really f of x, right? They are the same. And so that's kind of our conclusion that we're going to get down here. Now, what happens here is in our original f, we're replacing each x with this. Expand, that's going to be x plus 5 minus 5, and we get x.
Okay.
Yes.
What was that word that describes the function in a function?
Composition of functions. Yeah. Oh yeah. So we didn't look at when I said we didn't look at it this year, we did last year. It's really in composition, so we will look at it again this year. But we haven't done it yet. You remember from last year. Okay, so this is kind of combining those two, the knowledge of inverses and then the composition of functions that we've done already. Okay, so take a look at what it's actually saying here. So this is f of the inverse of x. This is saying the inverse function. So that's this. Okay, so f inverse of f of x, which is negative x minus 5. Now, that we already have. So when I do that substitution, it's the same function. So it's going to look exactly the same. Okay, because this f inverse, these are the same. So our math is going to be the same. We're going to end up with x plus 5 minus 5 equals x. So these are the same. Okay, now it's been fixed here. Oh yeah, so these are the same. We fixed the actual wording here because this is obviously the same. And so what do you notice about if we ask you to do f of x in this question? Well, it's going to be the same as well, right? Because f of x, so this would be, here. So f of negative x minus 5. F is negative x minus 5, right? So it's exactly the same. Okay. So if you take the function composition of a function with itself and you get x, then they are called self-inverse functions. Okay? Just a new terminology. So, you can either find the inverse. If it's the same as the original, you're good. Or you take the function of itself. Okay, so here, I'm just going to fix this here to make it look like you're, because when I made this up, I was a little bit repetitive and not very clear, so we fixed it up. Okay, so f of the inverse of x, composition, will be equal to f of, so the composition of the function with itself will equal x. Those are self-inverse functions. So if you're asked to determine if a function is self-inverse, you can find the inverse, take the function of itself, see that equals x, or a little bit faster is f of itself, okay, rather than taking the inverse, right? That's often easier because with the inverse, sometimes, especially if it's a fraction form, you have to then multiply through to get rid of denominators and that kind of thing. So this, I would say, check and see if, so you can label this f of x, and now I want you to find f of x. It will require good attention to detail with fractions and variables and stuff, but a little bit easier than taking the inverse. So you can have some fractions within a fraction. That's why we learned that back in math 10. Fractionals and fractions, complex fractions, all that kind of stuff. So take a look at, I've used red and kind of help you. So you're taking that original function and you're putting it in to wherever there's an x in the original function. Now, I would not expand out. I would not find common denominators between the terms there. You can remember how to get rid of those denominators in a fast way. Call it a complex fraction because there's fractions within a fraction. Or give me just one method of how to do it. Marcus? No, not binomial conjugates. You're thinking of a radical expression. So, yeah, we do it there. Yeah. Mm-hmm. Yes, why? Because x minus 3 is what? Yeah, so x minus 3 is a denominator here and here. There are no other fractions within the fraction. So x minus 3 is the lowest common denominator. So multiply top and bottom of the big fraction by x minus 3. Remember, that doesn't change the value of your rational expression. And put brackets around the numerator and the denominator. And then think about, I've got to distribute this bracket into this term and this term, and this term. By doing that, if you've chosen this correctly, these go away, right? This x minus 3. So I'll get 3 bracket 3x minus 8 when I multiply that arrow. Then minus 8 times x minus 3. Okay, then here, x minus 3's divide out, so I'm left with 3x minus 8, and then minus 3 times x minus 3. Do not start dividing out x minus 3's, or 3x minus 8. They are not common factors, so I cannot divide those out because this isn't subtracting in between them. Okay? Just expand now. Pull out like terms and it works out nicely. Well, not in our universe, but. Okay, so f of x equals x, therefore self-inverse functions. Okay, now do the same for the next one. Maybe I'll call this one g of x. Again, good attention to detail, right? Part of being good at math is actually just having good attention to detail. You don't want to miss a bracket, miss a term, miss a plus, whatever. So that's kind of why sometimes I just set out the original function, and instead of the x, I put brackets. Because now I'm going to take what's in there, which is g of x, and put it in here. Well, g of x is that whole thing. Okay, that denominator is nice. That adds to 0, right? So here, yeah, you can multiply top and bottom by x minus 4, or think about it, you're dividing 2 by 2 over x minus 4, right? So invert and multiply. Go back to junior high, kiss and flip. Right? So the 2's will divide out, and you'll just be left with x minus 4 plus 4, which is x.